things from others, and when they hear anything, they directly believe it. Like, say, if your neighbor said you need to do a lot of mathematics, otherwise you cannot be good at CAE, or someone says you need to learn a software, you need to have software proficiency. If you have that, you are a CAE engineer. So let me bust or debunk some common misconceptions about CAE that people have. The first is computers do everything. So this is not the case. Computers are like calculators to solve all the complex stuff or complex equation in the background. CAE requires a human brain to solve problems. And by human brain, I mean he requires all the basic knowledge, fundamentals in step one that I mentioned. He should have engineering judgment and he should have decision making ability. So by combining all these skills, he can be a good problem solver. And computer is just a part of it. It is just a tool for EA engineers to like accelerate their process of problem solving. So the next misconception is learn software and become a CAE engineer. So as I said, choosing a domain and having proficiency in the fundamentals. These are the basic prerequisites before learning any software. And I hope you have already understood it, why choosing a domain is important. Learning a software will only make you a tool operator. As my mentors, I have got good mentors. So I learned this very early on, that why choosing a domain is important. And software is just a tool. It's not like you press some buttons here and there, the computer does everything and you directly get the output. This is not the case. The third misconception is CAE and simulation are the same thing. So again, I would say simulation is like visual representation, or you can say visualization of the results or the animation. It is just a small part of the whole process. The whole process of CAE revolves around pre-processing, analysis, post-processing, and again report preparation. So simulation is a part of post-processing, we can say, where you get to see the results, where you get to see how the component will behave under some set of applied load conditions. You can judge if the deformations are going right as you expected, or if the component is behaving as you expected as per the boundary conditions. So many people, what they come across posts on LinkedIn where they see colorful animations of a car getting crashed on a wall, or aerodynamics of a car or aeroplane, something stuff like that they come across, and they directly judge and decide, yes, this is CAE, this is simulation, and I want to make a career in that. So before making any snap judgments, I would suggest first understand the whole process of CAE. Then the fourth misconception that people have is you need to have a master's degree. I have come across these misconceptions a lot of times in my career so far. So let me clarify. If you are having a master's degree, then it is a plus point. I'm not denying that you shouldn't have a master's degree, but if you are having it, then it is good, because some companies, some OEMs even prefer such candidates who have a degree of MTech, because what their perception is, if this guy is having MTech, he must be specialized in some particular domain, and if he is a specialized person, we can hire him to help us solve our problems in that domain, or debug some models, or come across any new challenges, because he is an expert. So that is also correct, because such companies, they require quality of that type, but it is not a necessity. It is not necessary to do MTech in order to start a career in CAE. I also didn't do MTech. Even a lot of my friends, they are not MTech, and they are right now working in OEMs and tier 1 companies, MNCs in Pune. So it is not a necessity. You need to understand this. And the fifth misconception is you need to know a lot of mathematics. So now let me clarify this doubt with an analogy, or with an example of a car and a driver. So imagine you are a driver, you want to drive a car from point A to B. So in order to drive, say, 10 kilometers from A to B, do you need to know how the engine is built, or how the powertrain system of the car interacts with the engine system? Of course not. You are a driver. Your job is to drive from point A to B. All you need to know are the traffic rules. So the mechanic should know how the engine is built, or how the powertrain, how various parts interact with the engine. Because if anything happens to the car, he will be repairing it, or he will be in maintenance person who will be operating that. So similarly, the driver in this case doesn't need to know how the engine works. Even the mechanic doesn't need to know how to drive a car, or he doesn't need to be a driver in this case. So similarly, now apply this analogy to CAE. Imagine a car as a CAE, the driver as a CAE analyst or a CAE engineer, and the mechanic as a software developer. So as CAE engineers, we are the end users. That is, we are using CAE to design something, to actually design some stuff. Whereas those who are mechanic or those who are software developer, they require knowledge of mathematics, that like partial differential equations, matrices, and numerical methods, because they will be making that CAE software. They will be working on that software. They will be working on making that software better or fast, or improving that interface. So that is also a good career option. I don't disagree with that. It is also a good career option, and there are a lot of companies out there like Altair or Ansys where they hire such engineers who know coding as well as uh, this mathematics. So they will hire such people. And but as a CAE engineer or as a driver, you are an end user. You need to use engineering knowledge to solve problems. So you don't, in this case, you don't need to know all the stuff. Just as a driver doesn't need to know how the engine works, you don't need to know how the software works in the background, because it is a job of a software developer, not yours. All you need to know is basic engineering concepts. So I hope these misconceptions, all these misconceptions are cleared now. You have got some clarity, and we are at the end of this presentation. So now we will be able to take any questions from the audience, or if you have any more